Here, I will show you a shortcut when we are using integration by parts. I'm gonna solve this problem twice. The first way, every time I'm integrating, I'm gonna add c, and then on the second time I'm gonna solve this problem, I'm just gonna add plus c in the last integral, and both of them should be the same. Let's start with the first way. So this is every time I'm integrating, I'm gonna add plus c. Note in here, just to make sure this problem does not being solved by u substitution, I'm gonna do u equal to x and then dx equal to du. Now the integral on the top going to be equal to integral x, which is u, and then e to the u, and then dx is du. Notice in here, this integral is the same as this integral. This one in here with x variable and this one in here with u variable. So u substitution does not work in here. So now let's try to do integration by parts. Notice in here that I'm gonna set u equal to x and then dv equal to e the x dx. So u is equal to x, dv going to be equal to e the x dx. Note in here again, integration by part gonna be the integral on the top going to be equal to uv minus the integral of v du. So here what I want to find the terms du and v. So from u, let's take the derivative of this. It's gonna be du over dx. And then to find v, I'm gonna integrate dv. And that gonna be equal to e the x dx, which gonna be equal to e the x and then plus c. I'm gonna call this c, c1. Now, I'm gonna plug all of these, what I just found, into the integration by parts. So that's gonna be equal to u, which is x, and then v, which is e to the x plus c1, and then minus the integral of v, which is e to the x plus c1, and then du is just dx. Now, for the next step, I'm gonna solve this integral. So that's gonna be equal to x e to the x plus c1, and then minus the antiderivative of e to the x, which is e to the x. Then the antiderivative of a constant is just c1x, and then plus a constant, I'm gonna call it c2. Note in here, this minus sign gonna be multiplied by the whole integral of this. So now, this is gonna be equal to, I'm gonna distribute x to what's inside the parentheses. That's gonna be x e to the x and then plus x c1, and then I'm gonna distribute the minus sign to the inside of the parentheses. That's going to be minus e to the x minus c1x minus c2. Now notice this term, minus c1x and then plus xc1. These will cancel each other, and we'll end up with x e to the x minus e to the x minus c2. Now I'm gonna equal minus c2 equal to c. That's going to be now x e to the x minus e to the x, then plus c. Notice e to the x, this is a common term, so I'm gonna factor it. It's gonna be e to the x, then x minus 1, and then plus c. And that is our antiderivative. The second way, I'm gonna solve this, but I'm gonna add only plus c in the last integral we have in this problem. So I already know that this problem can be solved by integration by part. and we already set u to x, and then dv equal to e to the x dx, and then du as dx, and then v as the integral of dv, which is the integral of e to the x dx. It's going to be equal to e to the x. I will not include plus c in here. I'm gonna just include it at the end, that is in the last integral. So the integral on the top going to be equal to uv minus the integral of v du, and that's by integration by parts. Here u is gonna be equal to x, and v is e to the x, and then minus the integral of v, which is e to the x, and du here is just dx. Now I'm gonna find this integral in the next step, so that's gonna be x e to the x, and then minus e to the x, and this is the last integral we have in this problem. Therefore, I'm gonna add now plus c. Now, notice here, e to the x, this is common term, so I'm gonna factor it out. So we have e to the x, and then x minus 1 plus c. Notice in here, this is exactly the same thing we found from the first way, but this is a lot shorter and it makes the computation easier.